Hello and welcome to this lecture. In this lecture, we'll be doing AutoKeras object detection, and for that, we're going to import our packages, which is TensorFlow STF, and also we want Keras, so we're going to simply take Keras from the TensorFlow. I'm assuming you don't have the AutoKeras, so go ahead and do the pip install AutoKeras. So I've already done that, so all the packages are now installed. The next thing is I need to import my dataset from TensorFlow. So I'm importing MNIST dataset from tensorflow.keras.dataset. Then I'm importing the AutoKeras as AK. Let me run this out. Now I need to load the data from the actual MNIST package. So I'm going to do mnist.load data. And this is where my training and test dataset is assigned, which is xtrain, ytrain, and xtest, ytest. Once this is complete in execution, go ahead and do the print for the shape. So I can see the shape of my data frame for xtrain.shape and ytrain.shape is roughly around 60,000 rows and 28 columns, right? And same thing for ytrain.shape, I have 60,000 rows and one column. Now I'm going to go ahead and create the neural network architecture by stacking the image input on image block. For that, I'm going to do ak.imageinput. So my input node is created. Now I need to create the output node. For that, I'm going to call ak.imageBlock, and I'm going to pass the input node, right? And the way in AutoKeras image CNN block works is if no block type is assigned, then it will search, select, and tune automatically from ResNet, exception, and vanilla blocks. Over here, now we have created the output node and input node. Time to do the classification. For that, I'm calling classification head as a factory method from AutoKeras, and I'm passing output node over here so that my output node is ready. Then basically I'm gonna create my model by calling ak.automodel, which would take different params. The first param is input, which is input node. The second is output as output node. Then the other two params are overwrite is equal to true and max try is equal to 20. Once our model is ready, we need to just fit it. So we're going to call classifier.fit xtrain ytrain, and we are defining number of epochs is equal to 3. Now remember that this can take several minutes. In this case, it took me 13 minutes, and my validation loss was 0.03. And total elapsed time actually took 2 hours and 8 minutes. So I won't be executing this over here since it's going to be taking a lot of time, but it's assumed anytime you're running, um, remember that it can take a couple of hours, right? Now I'm going to print the accuracy by calling clf.evaluate xtest, ytest. And if you observe, I have accuracy of 99%, right? 99.29%. Now that we have accuracy, I'm going to export my model by simply calling clf.export model. And I can go ahead and also print the summary of the model, which is model.summary. And if I give a print, you can see the number of params across the training of different layers. While normalization, 3 params were utilized. In convolution 2D, 320. In 2D 1, 36,000 parameters were utilized. Likewise, if we tally, the total number of parameters exceeds more than 100,000 params. And non-random params are 3. All right. Now, friends, we have seen how to use AutoKeras model. It seems pretty obvious that using AutoKeras you can auto-tune the model and then build more accurate models, even though the latency of execution can take some certain time. But that's the caveat you have to take while leveraging the AutoKeras. I hope you guys enjoying the lecture. Stay tuned for my lectures. Thanks for joining.